Hi guys, probably you've heard I am not in today. However, I have created this video to help you along with today's material as usual. So let's get started. Our learning target for today, which is October 5th, happy October month. I can identify the three states of matter and analyze the effect phase change has on density. We're really going to focus a little bit more on the three states of matter and the effects. Not going to focus that much on density, but we will talk about it. So you have this image in your notes, and in your notes, it asks you to go ahead and write some observation as well as a general definition for each state of matter. So I want you to go ahead, take the next 3 to 4 minutes, and do that. Pause the video right now and do that, and then press play again, and then we'll get started. So at this point, if you pause the video, you are back, and let's get started. So we have gas, liquid, and solid. You've heard about these states of matter from since second grade science, right? You've all heard about it. So when we talk about states of matter, this is what we're talking about. When it comes to identifying the states of matter in for a substance, you're usually indicated with either a G for gas, an L for liquid, and S for solid. So you'll see that next to the chemical in parentheses, right? You might also see AQ. Now, we'll talk about what AQ is in a moment after we talk about these three, but to identify what state of matter our substances are, they're usually written in parentheses next to the chemical. So, gas, we're going to start with gases, has an indefinite shape and volume. This is the actual definition. Particles are very spread out and they will collide with each other and the container. So, as we can see, with the gas particles we have over here, they're all floating around and they're all random, right? So, because of that, they can't really form to whatever container that they're in. And it's really difficult to find the volume. We can find the volume, but it's difficult to find the volume. All right, and particles are very spread out. They're really random and they like to collide with each other a lot. All right, and then when we go talk about liquid, you notice the particles are a little bit closer together. So here we go. Has an indefinite shape and definite volume. Particles are moving, but not so freely due to the container. All right, so we do have we do have when we come to a liquid, we have an indefinite shape because the liquid takes the form of any container that it's in, but we can't find out the volume because we use milliliters to do so. The particles are moving, but not so freely due to the container. They are able to move around, but not as much as gas. All right, let's go to solids. Now, solids has a definite shape and volume. Particles are vibrating in place due to the rigid structure. Now, the thing about solids is very funny because everyone assumes that solid things don't move, but actually they're really finite. So we'll notice that there's a very slight vibration. You won't see it to the naked eye, but if you look at the microscopic level, you'll notice that the particles are actually really vibrating in motion. Matter is always moving, so even as a solid, right? And because it's a solid, we can have a definite shape and we have a definite volume that we can calculate, usually by um, centimeters cubed, right? So I did say we were going to talk about aqueous, and aqueous is the AQ. It's not here, so just listen to me. Aqueous is AQ, and AQ basically means aqueous. I like to always think of agua when you think of aqueous because aqueous means that the substance or the chemical has been mixed with water. So anytime you're dealing with an aqueous substance, it has been mixed with water. It is still liquid, but it's been mixed with water. The base is not fully the chemical. It's been mixed with. Hopefully that helped. Hopefully you use this to fill in your notes. And let's get moving. So, we also have this image, and like I said, you've been dealing with states of matter for a while. So I want you to brainstorm on how we get from one state of matter to the next. How are we going from solid, liquid, gas? And then, is this reversible? Right? We're still sticking the mind state of physical changes because there's no chemicals being added. So how do we go from solid, liquid to gas? And is the process reversible? Go ahead, pause this, think about it for a minute, and then come back. So if you've paused me, you're now back, and let's talk about this image. So as we go from solid, liquid, gas, how do we go from solid liquid? How do we go from ice to water? That's very simple. We are melting, right? And then how do we go from liquid to gas? And it's very simple. We are boiling, right? So we are melting when we go from solid to liquid. We are boiling when we go to gas. Now, the thing about this is we don't all of a sudden just start melting. We have a melting point. That's the temperature in which we start melting. And we don't just start boiling. We have a boiling point, and that's the temperature in which we start boiling. So once this temperature is reached, that is when we have melting taking place rapidly, or this is where we have boiling taking place rapidly. All right. So can the process be reversed? And if you said yes, you are correct. So when we go from gas to liquid, it is condensation. Condensation, right? This is thing you need to remember. It's always easier to go from solid to gas, but when we talk about either or, we get a little confused, right? So as we go from gas to liquid, we are condensing. Um, think of a rainy day, a rainy hot day, right? When you see a lot of water particles forming, that is condensing, especially if it's like hot in one location and then cold in the next location. You see water particles forming on like the windshield. That is condensing. All right, and then as we go from liquid to solid, yes, we have freezing, and that is happening. Um, like I said, for boiling and melting, we have freezing and condensing points. This is where those substances will start freezing and those substances will start condensing. Um, One thing I wanted to also make sure you know is that the temperature at which it boils is the same thing as the temperature at which it would condense if it was reversed. So if it took 125 degrees Celsius for it to boil, at 125 degrees Celsius on the opposite direction, it will start condensing, right? So once you reach that and you drop lower, we will start condensing. 125 above, we will start boiling. Same thing with melting and freezing, especially when it comes to water. Once water you start melting at 0 degrees Celsius if the temperature were to increase, but you will start freezing at 0 degrees Celsius if the temperature were to decrease. So really, even though these two functions, right, we have melting and boiling and condensing and freezing happen at similar temperatures, it really depends on the temperature increasing and the temperature decreasing. One thing I also wanted to mention is that you can go from solid to gas like that instantaneously. And that is known as sublimation. Sublimation spelled Sublimintion. You can go from solid to gas instantaneously. We're going to talk about that a little bit tomorrow. But you could also go from gas to solid instantly. And that is known as deposition. Deposition, which is spelled as Deposition. Deposition. Right. Basically deposit should. Right. So that can happen instantaneously, but we're going to talk a little bit more about that tomorrow and work on those definitions a little bit tomorrow. So the thing about this image and this image is that they can and they will represent each other, right? So this image can be represented as a graph. So I want you to take a few moments and see if you can label each line segment of this graph with the information here, right? So go ahead. You will not need freezing condensation. Don't worry about that. But see if you can use solid, melting, liquid, boiling, and gas to help you fill in this graph right here. Pause it, take a few moments to do it, and then come back. Always try to challenge yourself with these videos. So if you paused, and now you've unpaused me, you've tried it. So let's see if you got this right. So we have line segment AB, and I always feel like it's easier to do this. Each line segment in which we see a change in temperature represents a state of matter, because only then do we see the temperature move. So AB will represent a solid, CD will represent liquid, and EF would represent gas. That's only where we see temperatures move. So what does BC and DE represent? Very easily. How do we go from solid to liquid? We are melting. And how do we go from liquid to gas? We are boiling. We also like to call that vaporization, so that's fine as well if you're using that word. All right, so each line segment represents a state of matter, and it will always represent a state of matter. So the thing about this graph is this represents a heating curve, so heat is increasing. Now, if I ask you, can this process be reversed? You would tell me, yes, this process can be reversed because we can go from gas to liquid and liquid to solid, right? You would just switch B and melting and boiling with condensing and freezing, right? And that location where C is written is the melting point, and that is the region in which we have full, complete melting of the solid, right? That's when it truly becomes a liquid. And over here where E is, that's where we have the boiling point. Once again, that's where we truly have complete boiling of the substance. And that's when it truly becomes a gas form. All right. Hopefully this helped. There's a couple of readings. There's a whole bunch of practice. I want you to go ahead and complete that. If you have any questions, please do contact me on Remind, email me, or put it on Google Classroom. Mr. Schwartz will be available during the class periods. Class periods for period. Sorry, I can't remember right now. He will be available for period 6, so you can go ahead and ask him questions then. We will review this a little bit tomorrow, but I really want you to focus on knowing the states of matter and being able to label the graph with the states of matter. If you have any questions, like I said, please contact me, and have a great day, guys. Happy Monday.